Yo, I'm Sunir, and I'm a 19-year-old engineer, and I build vehicles for humans to transport themselves and for other purposes. And currently, I'm focusing on automated vehicles, and this is the car I'm currently working on. And so, I'm going to go through the different components of the car first. So, there's the Raspberry Pi 4B we're currently using. We might later on use Jetson Nano for more compute-heavy stuff, but for now, the Raspberry Pi is just enough. And this is the servo driver we are currently using, and it's connected to the Raspberry Pi with the wires, DuPont wires here. And we're currently, as sensors, we're using only one sensor, which is a Pi camera, and that's enough. That's good enough for us now. And this is my first time using a Raspberry Pi camera. Previously, in my previous car, I used a webcam, and it was much more easier to connect. And you might argue there are much more benefits to a Pi camera. There might be, but it's a real pain in the ass to connect the car, the to it to a car. Sorry, to the board. You just need to have extraordinary engineering skill to basically connect this thing, and without breaking it, and especially if you are doing it for first time. So I had to watch a tutorial and like read a bunch of guides so I just don't break it. And I think I didn't break it, and it works. And yeah, so that's about it for the camera and the sensors. And I'm going to go about the power later. It's a fun part. And so this is a 40 pin connector for the Raspberry Pi. I had to learn more about it just so that I connect it in the right pin. And we connected it to the pin heads here in the servo driver. And most of the people, they really are like they get stuck on this part, connecting a Raspberry Pi to a servo driver. And the reason they get stuck on this is because they're really worried about messing up the wiring. And I'll like literally bet $100 on you that you won't mess up the wiring unless you are like messing up the power and the ground. And even if you're messing up other things, only thing that will happen is you'll get an error on the screen, and you can basically swap out the wiring and you're good to go again. And just don't mess up the ground and power. And it's pretty easy to figure out because it's literally written here. And about other wiring, so there's a very fun part about wiring, because what happened was my previous plan was that the wiring that came with the car, so this is a ESC stands for electronic speed controller, and that's connected to a RC unit. RC stands for remote control, and that's connected to a remote control that comes with the car. So initially this was a remote control car, and there's a bunch of wiring there. So my plan was I would use the wiring there, maybe change up a pin head, and just use that wire. Like, why would I need more wires, right? But the problem was that this was a cheap car. Like initially, this was not a very expensive car or anything. And the wires were really cheap, really thin. And second, it was very short. So just if it was just like very thin wire, I would have like, it was like good enough. But it was short. I could not literally like connect like bring it up here and like connect it to the servo driver and like connect like both of these components. It was not long enough. So what was the solution? Create your own wires. Like you can create your own wires. Only thing you need is this. So a pack of like DuPont wires, and so each pack is like under $5, and it has like male to male, male to female, and female to female. So you can do bunch of things with it. Cut up the wires, maybe cut both pins, add your own head. And so I found out about a new head I didn't know about before, and you can buy these as well. I think it's called like JWT pin or something. And you can basically extend your current as far as I know, it's called like JWT pin or JWS, something like that. And you can basically, there is an extension, literally you can buy the extension wire as well. So you don't need to create your own wire as well if you don't have maybe a DuPont wire pack or something, and you don't know how to create your own wire. You can learn, obviously you can learn if you want, which is fun. But if you don't want to do that, you can also buy extension cables. You don't need to buy you don't need to stop your project just because of that. Like create your own things. And about the power, so this week we went from 1500 milliamperes to using 11,500 milliamperes. So this car as a whole unit currently uses 11,500 milliamperes of power. And that's just because of this power bank, this beast up here. And this is a standard LiPo battery that comes with the RC car. Not a very expensive one, but pretty good compared to the I think it's called NICMH or something. It's not the cheaper ones that usually come with non lithium ion battery. It's much more better. This is a lithium battery, and I went for the extra battery power. I went with the power bank instead of a standard LiPo battery for a car. So this is not a standard car battery. So this is like a regular power bank from Anker. So the reason I went with it is because it was significantly cheaper. It was like 25 bucks for this, and but the problem was that because it's not for the car, it's like it's everything is not like built for the car, so it was extremely slippery. There was no place to keep it, and most of the tutorials and stuff, they basically put the battery down here, like, and they zip tie it, and the problem was this was so big and that it couldn't fit inside here, because I have a really big ESC here, and also I'm going to talk about this fan thing here later, but there was an ESC here, and on the other side there was a brushless motor, which is much bigger than the regular brushed motor, and there was no place to keep this battery. So what we did was basically added up the battery on the top, because it looked fine, it seemed fine, it drives fine, so it was good. So I was planning on initially keeping it in a wing, but it was too slippery, so I just added in here. And for solving the slipperiness part, what we did was we basically used a newspaper rubber band. And someone told me, a good friend told me, that to use a bicycle inner tube, but I don't have a bike and I can't find a bike. You can go to Stanford and like find lots of cheap bikes, like lots of bikes there, but the thing was I don't live in Stanford, and I don't have a bike near me, so just where can I just like remove the inner tube? So I basically found this like newspaper like rubber bands at work, and just tied it up, and it solved the slipperiness problem. And I didn't have a zip tie, so I basically used this Velcro tape. It doesn't work the best as like a zip tie, but it does the job. It does the job of like keeping the battery together. It doesn't fall off, and it doesn't like go backward when the car is at full torque because of the grip, and it doesn't like shake on the other side because it's tied it up like really good with the Velcro tapes. And if everything fails, I'll just like super glue it. Doesn't matter, right? We just need to make the car work for now. So that's about the power. And obviously most people would like probably argue with me that, hey, like it's not something to brag about, the power, because you're adding in like way more weight, so it's not something to brag about. I would definitely brag about it, because one, you add like significantly longer runtime, and second, you can add in more components just because you have more power. And this 1500 milliamperes power battery, it like runs out really quick. And you can obviously, if you can afford it, you can buy way more better batteries than this power bank, like standard like car LiPo batteries. They are specifically designed to be kept on a car. They can be like zip tied together really well, and they have better pin connectors like this. This is not the best one, but much better than what this comes with. And for this, you can create your own wires again, but you have more extra work if you go with the cheaper option. But if you can afford it, you can go with the RC batteries, like LiPo batteries from Traxxas or something. But if you cannot, power banks are just good enough. And other than that, most fun part, I would say, is that at this point, about a week before, I posted a video of saying I was just like carrying a car like this, and you see none of the components fall off. And I'll tell you about the more efficient way to like screw things in as well. But I posted a video about showing you the crazy acceleration of this car, how like extreme like torque it has, and about a week before. And from that point to this point, everything has been replaced, everything. So there is not a single part of the car that's not unopened, unreplaced. Everything has been opened up, every screw has been opened up, replaced back in. So it is not necessary. So if you're planning on building a car as well, it's not necessary to like build the everything from scratch, like not just like so when I say I replaced everything, I mean by not just in electronical level, not just in like ML level. ML was not, so basically machine learning and the self-driving unit part was not even a thing in the RC car. That is something I added in. But even in electronics level, most of the people just like start with the electronics level, replacing that, and go like on top of it. But I really wanted to understand the vehicle mechanics. I really wanted to understand how the four-wheel drive works. I really wanted to understand how the like rear axle and the frontal axle works, because this is the previous car body, the chassis that I used previously, and this was using a webcam, completely different car. This is not a four-wheel drive car, and completely different steering mechanism, right? And different shocks. This was not an oil shock. There was just a spring shocks, and this car, I didn't know how to like basically did I wasn't a good of an engineer. I just copy pasted code for this, but I really didn't understand the vehicle mechanics, and it's I don't think it's like necessary, but it's like really helpful. When you understand something from like ground up, you can basically understand what is like extremely important to make something work, and what is not extremely important to make something work. So I basically removed these components to reduce some weight and basically also reduce some like power uses, which is basically this like fan. So this was creating like a lot of noise, and which was cool, right? Like you just know the car is on, but the thing is, it was completely unnecessary, because it was like necessary and like useful when the car was a remote control car, because it was cooling the ESC. But we added in our own 3D printed board, so there was no enough ventilation for the air to leave. So this was pretty much useless. It was just like a fancy stuff that created like just a lot of noise and used a lot of power. So just remove this, and I built everything from scratch, from like the rear axle, drive shaft, and everything. So I can basically remove this entire rear body adapter as well if I want to reduce the weight and add in more sensors, and maybe this Jetson Nano, which is like much more heavier than the Raspberry Pi. So it has its own cooler, and it's attached with the Pi camera right now. But so this is much more heavier. So I can basically add in more battery and add in more components, but I can remove the existing parts. Like I can remove the RC unit of the car, which is because I don't want to make it like remote control anymore. It's like it's a self-driving car. So I can do that, and this was all because I built everything from scratch. So that was the most fun part. I was able to understand how the vehicle mechanics work, and basically how the car works as a whole. And once again, it was not necessary, and not I don't think there was everything went perfect there. I thought it was like a pretty stupid thing I did at first, because what happened was I faced this problem of car not driving straight. I did this, I opened up the car, and luckily my car came with this manual, and it turned out to be English manual. The previous one came with like a Chinese manual, which was extremely hard to understand. But this one was, everything was in English, so I could basically open things up and basically place things back in together. And there was not like a guide for every single thing, but it was very helpful, much more helpful than something like you don't understand at all. But that was extremely helpful, which helps you understand what is what each component does, and like what your goal is. And if that component is not really supporting that goal, you can basically remove that and reduce the weight, or maybe reduce the power uses or something, right? And that was like extremely helpful. But the problem I was talking about was that the car was not driving in a straight line. The car was driving in an angle. So the car had to basically, the tires, the frontal tires, the steering tires, they look straight, and I can basically do that with this remote control as well. So there's like a steering calibration thing here, and I can basically like adjust the steering tires, like the straightness with this. But even though I make it straight, but when car starts driving, it would just basically start turning in a right. So it was always in an angle, and I couldn't fix that for a while. And to be honest, it still doesn't drive straight, because just because I opened everything up, it still drives in a bit of an angle, not in a completely straight line. And but it's good enough. It's just good enough, and I think it was totally worth it to damage the car a little bit, just so that I learned the bare bone mechanics of how the entire car works in a vehicular level. And yeah, I think it was totally worth it, and I really enjoyed doing that. And about I already talked about the wiring. I already talked about the mechanics of the car as whole. And also, if you want to, what you can do is basically change the wiring for the motors as well, so that it's like easily detachable. So, and also you can change the pin heads for the battery. So basically what most people do is they basically, this is my multi-tool scissor, and uh, you can basically cut this off and attach a much more bigger like a pinhead, so that it's easier to charge and easier to charge and much more universally adaptable. And you can do that, you can play around with that. It's a lot more fun, and especially if you have a soldering iron. I don't have a soldering iron yet, but you can like still like borrow someone's soldering iron or go to some hackerspace and find a soldering iron and do that. And yeah, and so far the especially the building the car from completely from scratch at this point has been like a really great experience. And did lots of bunch of other things, like hacked on like bunch of other stuff, like reverse engineer some of the things. And so this whole week was a lot of fun. And other than that, it was a great week. Thank you so much, and it was a pleasure chatting with you guys. If you have any questions, please feel free to reach out on Twitter or just like comment down below. And thank you so much. Have a great day.